Okay, illustrative math, unit 2, lesson 21 is called rational equations, part 2. All right, so our goal today is I can write rational expressions that represent averages to answer questions about the situation. Now, obviously, there's many different real world situations where you could use a rational expression. We're just going to do a couple of them and kind of just get a little basic level understanding on this. All right, so the first one, solve each equation mentally. So pause the screen, try to take a look at this and see if you can figure out a value that would work, and see if you can do it mentally. And I'll do it algebraically as well. So I look at the first one, 3 out of 4. Well, since this is only 2, if you break it down into halves, we'd have 3 halves out of 4. Think of like a pie chart. So this one, I can kind of mentally get x equals 3 halves or 1.5. Okay. Now, algebraically, this is called a proportion. So you're going to cross multiply with the proportion. So we get 4x equals 6. And when I divide by 4, there's the algebraically. And I have to reduce it. I get x equals 3 halves. 1, 6. So x would have to be 18 to get this to 3 over something to reduce down to 1, 6. So I'm mentally kind of doing it. Again, algebraically, cross multiply. 18, 3 times 6 is 18, 1 times x, there you go. This one, if you plug in 2 and square it, you would get 1/4, but you could also plug in -2 as well. So 2 and -2, 2 answers on that one. If I wanted to do algebra, cross multiply, I get x squared equals 4. And then when I square root both sides, I get x equals positive and -2. And then over here, well, obviously, if this was 8 and this was 2, that would work, right? So, but wait a minute, x can't be 2 different things. So, oh man, you might have to do a little trial and error here. So this one might be a little bit harder. So start plugging in some numbers. We'll do it algebraically. X times x is x squared. 2 times 8 is 16. Okay, so there's where the algebra comes in. If you can't do it in your head, there's your answers there. So x equals 4 and -4. Okay. All right. So Noah likes to go for boat rides along a river with his family. In still water, the boat travels about 8 kilometers per hour. In the river, it takes them the same amount of time to go upstream 5 kilometers as it does to go downstream at 10 kilometers. Okay, so before we do this here, let's make sure we realize upstream. Remember, well, first of all, let's remember distance equals rate times time. So upstream, your distance is going to be, your rate is really the speed of the boat minus the current, because you're going against it. So it's slowing your boat speed down. And then downstream, your distance is, your rate is now compiled from 2 things. It's from the speed of the boat plus the current. Okay, so your rate depends on if you're going upstream or downstream. So if the speed of the river is r, write an expression for the time it takes to travel 5 kilometers upstream, and an expression for the time it takes to travel 10 kilometers downstream. Okay, so upstream, your distance was 5. So I'm going over here to this formula. Your rate is upstream, it's going to be the boat. So the boat travels at 8 kilometers per hour. If you look right here, the boat in still water. So the speed of the boat, if it was in still water, would be 8 kilometers per hour. So it's going to be 8 minus the current. I guess they're using R for the river. Okay, maybe I should have used R here. Let's do that. Let's keep it consistent. The boat plus the river. Okay, boat plus the river. All right, so distance is 5, speed of the boat in still water is 8, minus the river times your time. It takes them the same amount of time. So what would my time be here? Well, I don't see anything, so I'm just going to put T. All right, downstream, which I didn't really like this because it has 2 variables, but we'll figure it out here as we go. Downstream, your distance is 10 kilometers. It's going to be the boat plus the river times time. Okay, so there's my 2 expressions, okay? Now, I can move these around. What would be nice is if I solve them each for t. So if I divide this by 8 minus r, and I divide this by 8 minus r, these will cancel. So now this is the same equation, I just manipulated it around. It's a 5, not an s. And then same thing here, divide this by 8 plus r. Those cancel, so I get my time equals 10 divided by 8 plus r. All right, use your expressions to calculate the speed of the river. So since these, it says it takes them the same amount of time. It takes them the same amount of time. So I can say, oh, well, if I set these equal, because they're both equal to t, I could now have an equation here. And there we go. So what I could do is I could treat it like a proportion. I could cross multiply. So I'm going to get 5 times 8 plus r equals 10 times 8 minus r. So from here, it's just algebra 1. So it's 40 plus 5r equals 80 minus 10r. And then I just got to keep scrolling down here. Combine like terms, minus 40. Add 10r. So I get, what's that, 15r equals 40. So your rate is 40 over 15. Let's see, what does that reduce to? Around 2.7 kilometers per hour. Okay. All right, next one. Circuits in parallel follow this law. The inverse of the total resistance, so that's the 1 over the RT is resistance total, is the sum of the inverses of each individual resistance. So 1 over, inverse means flip, 1 over resistance 1 plus 1 over resistance 2, depending on how many circuits you have. So where there are n parallel circuits and R of T is the total resistance. Okay, so here's your formula. So 2 circuits are placed in parallel. So we're not going to use this part. We're only really going to go right here, okay? First circuit has a resistance of 1 over 40, and the second is 1 over 60. And that's equal to 1 over your resistance total. So what is the total resistance of the 2 circuits? Okay, so what I would do now is I would probably combine these. So I'm going to get 1 over RT equals, let's see, what would my common denominator be there? 120 maybe? So it's going to be 3 over 120 plus 2 over 120 would give me 1 over RT equals 5 over 120. And then I can cross multiply and I get 5 times your resistance total equals 120 divide by 5, divide by 5, and I get my resistance total equals 24. 24 what? It's ohms. Okay, that's a unit there for measuring energy. All right, number 2, 2 circuits are placed in parallel. So again, kind of the same thing. We're only using this part of the formula. Second circuit has a resistance of 150 ohms more than the first. Write an equation for this situation showing the relationships between RT and the resistance R of the first circuit. So 1 over your resistance total. So the first one we don't know, it's 1 over R, but the next one is 1 over R plus 150, because if it's 150 more, you'd have to add 150. Hang on, let me erase that. There we go. All right, so there's my equation. It doesn't ask me to do anything yet. For the number 3, though, for this circuit, Claire wants to use graphs to estimate the resistance of the first circuit, R, if R of T equals 85 ohms. So it's 1 over 85. That's your total. Equals 1 over R plus 1 over R plus 150. So describe how she could use a graph to determine the value of, I should say R, and then follow your instructions to find R. So here's what I would do. I would graph Y equals 1 over 85. I would graph, write it in, it's probably easier to write it. Y equals 1 over R plus 1 over R plus 150. Probably have to use X instead of R. Maybe change the R to an X, because with Desmos and your graphing calculators, usually X is the independent variable. And then I would say here, adjust window as necessary. Sometimes when you zoom in, zoom out, it's really hard to see. So you might need to kind of change the X minimum, the X maximum, the Y minimum, the Y maximum, and then find intersection point. Okay, so I've kind of done like 1, 2, and 3 here. So if you go to this next slide here, here's the first one, here's the second one. And then if you notice here, my window, I kind of changed it because when I hit, they have that little like plus and minus button up here on Desmos. If I just keep zooming out, you're going to zoom out on both axes, which I don't really want to zoom out any further on Y. So they get really close together and you almost really can't see the intersection point, but Desmos will mark it. But so what I did is I made my window from -20 to, I don't know what I put here, 140 or 150 or something like that for X. And then my Y, I kept it really small because I didn't want to zoom out too far. I made it like, -1/2 to 1. That way I could see a little bit better. And then I just took my cursor and I clicked right there and I found that they intersect at 123. So remember, what does that represent? That was X, which I guess in my equation was R. If I go back down here. So basically 1 over 85 would equal 1 over 123 plus 1 over 123 plus 150. So what I would do is I'd probably take my calculator and just double check to see if 1 over 123 plus 1 over, would that be 273? That adds up to 1 over 85 or close to it, okay? All right, so lesson synthesis. So we're going to just kind of see how they got from here to there. So I was showing you how to cross multiply. Another thing you could do is get a common denominator. So if I multiply this by R over R, and I multiply this by R plus 150 over R plus 150, what we get is there's like kind of like an intermediate step here where it's 1 over 85 equals, if I distribute this 1, I get r plus 150. If I distribute, well, I don't have to distribute, I just get plus r. And then in the bottom, I'm not going to multiply it, I'm just going to leave it as r times r plus 150. Now you might ask, well, what happened? Why are there not two of them anymore? Because remember, we're adding fractions. So basically, when you add add fractions and have a common denominator, you keep the denominator the same. And then I can combine these two r's because they're like terms, and that's where I get the 2r. Okay. So then at this point, what they did here, instead of, you could cross multiply if you want, or what you could do is you could just get rid of this. So if I multiply each side by r times r plus 150, what happens over here is these cancel out. So that's why I only have that, because this is over 1. So these are diagonal. And then over here, it's really 1 over 85 times that. So you can manipulate these things around if you want, or you could cross multiply here. That would do the same thing. Everything would still be equal. All right, so I can write and solve equations with simple rational expressions on each side. Again, obviously there's many different situations. We're just kind of touching on this a little bit and playing around with it a little. All right, last one here. Cool down. Show that 2 over 4 minus x equals 10 over 4 plus x is equivalent to 12x equals 32 for all values of x not equal to 4 or negative 4. So let's talk about this, the 4 or negative 4. The reason that x cannot equal 4 or negative 4 is because if I were to plug in 4 right here, I get 2 over 4 minus 4, which is 2 over 0. You cannot divide by 0. If you type into your calculator 2 divided by 0, you're going to get an error on your calculator. So that's not going to work. So same thing over here with the negative 4. If I plug that one in here, I get 10 over 4 minus 4, which is 10 over 0. So you can't divide by 0. Okay, you can have 0 in the numerator, but you can't have 0 in the denominator. So that is the first part. So I would maybe write something here, along the lines of x cannot equal 4 or negative 4 because if I plug those values in for x, I get division by 0, which is undefined. So then let's see if I can do the rest of this and just show that they're equal. So I'm going to maybe start out with the cross multiply technique. So I take 2 times 4 plus x equals 10 times 4 minus x. And let's see what happens here if I start distributing. I get 8 plus 2x equals 40 minus 10x. So I want 12 on the left. So if I add the 10x to both sides, that gets me the 12x. And then minus 8, I get 12x equals 32. And that's it. I can stop right there. Now, if it wanted me to finish it, I would just divide by 12 and I would get x equals, I don't know, 2 point something, 2.67 maybe. But it didn't ask me to do that. So hope you enjoyed this video. Thank you for watching.